Yes, that's correct, Mr. Riconis. First, we just had a little bit, very short bit of follow-on testimony from Mr. Conklin, just 2-3 minutes, and then our next witness.
Okay, we'll swear in anybody who's going to testify this evening at this time. Proceed, Mr. Lewis. Wait a second.
Mr. Conklin, at the conclusion of the last hearing, several questions were raised for you about the emergency shutdown system. I think there was a little confusion there, so just wanted to go over that real briefly again. That system again is it operated and tested in accordance with federal requirements?
Yes, it is.
Okay, and what does it do?
So it monitors the process operating at the station and can automatically initiate a shutdown of the facility.
And what are examples of what would initiate a shutdown of the facility?
So for example, a gas leak within either the compressor building or some outlying areas of the facility, a fire detection in the compressor building, could be a high or a low pressure, for example, within the station piping, and also like a failure of the control system would trigger the system to shut down.
Now, when the compressor station is operating normally, I'm correct, there's no gas in the air inside the compressor building?
That's correct. It's contained within the piping of the facility,
Okay,
not
so,
in the compressor
and
building.
so one of the purposes of the ESD would be to detect whether gas was either in the building or outside?
Yes, that's correct.
Okay. What happens when an ESD is tripped?
The facility is shut down, and also the inlet and outlet piping is blocked. And so that prevents any gas from entering the facility. And additionally, the wells upstream of the pad will also shut to prevent any gas from entering into the pipeline system after the compressor station shuts down.
And what kind of testing does the ESD system get?
It is annually.
And is that a requirement of the federal government?
Yes.
And then just in general, in summary, what is the purpose of the ESD system?
So it's a fail-safe system to shut down the facility and clear the facility of any gas. And the system is fail-safe because we would want to prevent any more serious incidents from occurring. You know, for example, a spurious trip of the ESD system.
Okay. So it's better off having the ESD system than not having it?
Absolutely.
Okay. That's all I have. Thank you. Thank you.
I have a question. Who gets noticed when there's an ESD? Like who on your team, and then from there, who all gets noticed?
So, judging from past experience, that's something that would alarm in our SCADA system, which is our remote monitoring system, and that would generally trigger like an email and text messages to likely nearly all or all of the Olympus operations staff.
Okay. That's not something you would automatically notify anyone at the township, or would that happen?
I believe the capability would be there if we wanted to, with that SMS system.
Any other questions from the commissioners? Eileen Miskovich, any additional questions based on this additional testimony? Caitlin Bursick, any additional questions for this witness?
No.
Janet Roslin, any additional questions for this witness?
I just, again, would like to know what kind of cyber security system you have that surrounds this system, so that nobody could like tinker in and fake it out, so to speak.
So faking it out, I guess I'll try and address that first. So tripping the ESD system puts the facility in the safest state possible. So faking the system to trip it would actually put the facility in a safe state. And it is designed to do that. Like I said, that would be what I'd call a failure of the control system, for example. Our sites, all of our internet connections are behind next generation firewalls, which are spec'd out by our IT contractor. So there's not a direct route and from the internet via just a random cell node or something like that. There are firewalls at the facility.
If the system is going to notify the nearest operations staff, you said, how near could we reasonably expect such a staff to be?
So during normal operating hours, most days and most long days, the operators are making rounds, so they would probably be within, a half hour to 2 hours from the facility, kind of depending on where those routes are. Generally, I believe they're area specific. So it's likely that the operators that will be covering the facility would be nearby in this general area, covering like these well pads. At night, they could be at home, or there is typically an on-call person who would respond, who is dedicated to respond to such events.
And this is contract staff, or is it,
This would
will
be-
you be notified as a sort of head person of
So
operations?
I do not get the operations notifications, but the internal company operators do. And if there are contractors fulfilling some like operations roles, they can also get those notifications.
That's all.
Thank you.
Thank you.
Mr. Lucas, any redirect?
No.
Thank you. Mr. Lucas, you may call your next witness.
Witness would like to call Mr. Tage Rosendahl. And Mr. Rosendahl, you've been sworn, is that correct?
Yes,
Could you please state and spell your full name for the record?
Tage, T-A-G-E, Rosendahl, R-O-S-E-N-D-A-H-L.
And Tage, I know you employed,
Acoustical control.
and what is your position with acoustical control?
I'm the regional manager in charge of our operations in the Appalachian Basin in Canada.
And where is acoustical control based?
Fort Worth, Texas,
And how long have you been with acoustical control?
12 years.
And what are your job responsibilities?
I oversee our general operations, whether that's in some kind of sound impact assessment, any kind of monitoring activities, and then mitigation and construction activities.
When you say mitigation and construction activities, that you mean, is it fair to say you take the information you gather from either your monitoring or your sound impact assessments and develop the strategies to mitigate the sound?
That's correct, with buildings or barriers or silencers.
Have you previously testified at public hearings like this
I have.
for Olympus
I have.
and for others?
Yes.
And what would you estimate the number of hearings you testified at?
Probably 40 or 50.
Could you just explain, you mentioned ambient studies, could you explain what an ambient study is?
Yeah, it's just basically a study to assess what the background is, your general like noise levels of something during that particular period.
And what equipment do you use for that?
So typically, we use a Brule Car, B-R-U-H-L KJAER 2250 or 2270. But we've also used Larson Davis monitors and Quest monitors as well.
And what's the typical time period when you do an ambient study?
It varies, but generally 72 hours. We've done, shorter ones, 24, 48.
And then, what is your role at acoustical control with respect to ambient studies?
So, generally, I just oversee the entire project. So I work with the client to determine kind of where and what, and then I work with my technicians to, deploy.
And do you oversee and review and sign off on any ambient studies?
I do.
In your estimation, how many ambient studies have you overseen while in acoustical control?
Hundreds.
You also mentioned sound impact assessments. Now, ambient studies measure the noise.
Sound levels.
Existing.
Yep.
Like right now. What's the difference? What is the sound impact assessment?
So a sound impact assessment is basically trying to predict what the impact of noise will be on some environment. You can do that, manually, or we use computer software to do that.
And what data do you input?
So, if you can take a variety of noise inputs, equipment, whatever you're trying to model, and then you locate those, you take the topography of the area, you can take digital stuff, you kind of load that all into the software, and then you produce an impact map.
Like the one that we see on the screen up here?
That's correct.
And we'll talk about that momentarily. And what is your, generally speaking, when you do a sound impact assessment, how do you account for vegetation?
So we usually leave that out because it is an absorber of noise, and we don't necessarily know kind of the season that these operations are going to be out, so we omit foliage.
So you assume no foliage.
Correct.
How many sound impact assessments would you estimate? What's your role in the sound impact assessments?
Similar to the ambient, I oversee the entire project. We work with the clients to gather the appropriate information, whether that's manufactured data or field collected data, and then we process that, package it for my engineer. My engineer produces the maps, and then we put together the report, and I oversee that.
And how many sound impact assessments would you estimate you've overseen for oil and gas wells?
We've done over 100 of those.
And what about natural gas compressor stations?
Probably 15 or 20 that I've done. We as a company have done more.
Okay. With that, I'd like to move the qualifying Mr. Rosenthal as an expert in sound ambient studies and sound impact assessments for oil and gas facilities.
Any objections to the admission of this witness as an expert?
No. No.
Okay, you'll be admitted.
Was acoustical control retained by Hyperion to prepare a sound impact assessment for the proposed champion compressor station?
We were.
And what was your role with respect to that?
We worked with the engineer, Mr. Brody, and we put together the package of all the equipment, the building footprint, the location of the equipment, and we packaged that for my engineer to produce the impact maps, and go ahead. No, and then oversaw the project.
And you reviewed and signed off on the project?
Correct.
Okay. Now, it's fair, if I'm correct, that originally, acoustical control prepared sound impact assessment, assuming there would be 3 compressors, is that right?
We did.
Okay, subsequently, that was downsized, and the current proposal is for 2 compressors, is that right?
That's correct.
Okay. Now, the last hearing, we previously marked as Exhibit E, a document called Hyperion Midstream Sound Impact Assessment, 2 compressors. Is that the sound impact assessment to which you were just referring?
Yes.
And I know we handed out extra copies last time, but I know they tend to get lost in the shuffle, so I brought extra ones this evening. Now, the ordinance requirement for sound from a compressor station, just to kind of to summarize, is 60 dBA at the nearest protected structure. Is that correct?
Near 100 feet.
On the next to last page of your sound impact assessment, is that what I call propagation map? It shows the, actually, Greg, is there another screen? Sorry? Is there one more screen? Oh, yeah, that's, okay, oh, back up here. This one? Yeah, I guess this is a little big there. What's projected up on the screen is the same as the propagation map that's on the next to last page of your report, is that correct?
Yes.
Okay. And what are the numbers with the R on, what do those indicate?
So our numbers are receivers, so those are homes located around the proposed facility.
Okay, and for example, R1 located to the north of the facility, that's approximately how many feet from the compressor building?
1,300.
And I believe that may be Ms. Kovich's property or certainly near it. Similarly, R2 is just north of R1. What is the approximate distance from the compressor station building to that house?
Approximately 1,482 feet.
I believe that may be Ms. Bursick's home. And then lastly, R3 is located to the southwest of the compressor station. What is that distance to the compressor building?
It's approximately 1,509 feet.
And that the record show that that's Ms. Rosalind's property. Overall, what is the range of projected decibel levels that your SIA concluded would exist for those 25 receiver points?
So
From the highest to the lowest?
we predicted the highest impacted level would be R25 at 42.8, and the lowest would be R21 at 28.4 decibels.
Okay, and let's talk about the projected sound levels for the Miskovich, Bursick, and Rosalind properties. What does your study project the sound level to be at the R1 Miskovich property?
40.3 dBA,
And R2, the Bursick property?
40.5,
And R3, the Rosalind property?
41.2.
Now, all those, would you agree, are well below what the ordinance requirement is?
That's correct.
And do you have an opinion as to why that's the case?
Yeah, so the instrumentation and the mitigation efforts that went into the designing the facility are best in class,
State of the art.
state of the art.
Let's compare with that with, I think this is even in your report. What's the typical average sound level in a quiet home?
It's around 40 decibels,
And what about a quiet street?
50,
And what about a normal conversation?
60.
Okay. Did acoustical control take any ambient measurements in vicinity of the proposed site?
We did.
Okay. Was one of those north of the site near the Douglas Run Road intersection with Nichols Hill Road?
It was.
And that would be in general vicinity of R1 and R2, I think.
That's correct.
And what were your findings as to the projected, or the ambient levels in that area?
So over the 72-hour period, it was 53.43.
I mean, that would be the average, right?
Yep.
Did you also do a measurement to the south of the site?
We did.
And was that in the general vicinity of the Round Hill Road, Douglas Road, Run Road intersection?
Yes, sir.
And what were your findings as to the ambient levels over that 72-hour period there?
61.82 decibels.
And these are taken over a 3-day period?
That's correct.
And what was the general source of the noise?
Predominantly rodent noise was the,
And how do you know that?
well, I mean, so we have monitors that allow us to identify sound clips. So we use those sound clips to identify, you know, what a peak in noise is. So we set trigger levels, or in these cases, we set them on standalone functions, so they recorded basically the entire 72-hour period. So we can go through and kind of look at, you know, any spikes in the data. So if there's an elevation, we can kind of isolate that, go back and look at it, and identify what the noise sources are.
We came here tonight, did you bring a noise meter with you?
My technician did, yes.
Okay, and did the technician take some readings outside the building here?
He did.
And what did those readings show?
So he was outside for a period of about 20 minutes, and the average sound levels of the LA EQ was 53.43, and the max, LAF max was 74.49.
In conclusion, in your professional opinion and with a reasonable degree of certainty, will the compressor station proposed by Hyperion and as designed by Hyperion meet the Elizabeth Township zoning ordinance noise limit requirements?
Yes.
No further questions, thank you.
Any questions from the commissioners at this time?
I have a question.
Commissioner Walsh?
I don't really know first. Do sounds like add together?
Yeah.
So what's that like? How do they add together? Are they like 40.3 dBA plus 40.3 dBA?
It would be just a slight increase above, it's larger, it's not. Sorry. It would just be a slight increase above 40.3 generally. So kind of a general rule of thumb is if you take 40.3 and 40.3, it would be like a 1 to 3 decibel increase.
I didn't hear where you got this number from, but you said in one direction from the site, it was 53.43 the average, and then you said 61.82?
So those are the ambient studies that we did. So to the north, at the intersection near Nichols Hill Road, which is the closest to R1 and R2, we set a monitor out for 72 hours in October of 20. And basically the average over that period was 53.43. We also set one out south at the intersection of Douglas, Round Hill Road and Douglas Run, and that was 61.82. The 72-hour period, that was the average.
So average being like, average, so obviously then there was sound that were above that, right?
And below it, correct.
Okay. Okay, thank you.
I have a question. This map that's your exhibit here, I know that that's assuming no trees. Is that assuming an ambient level of 0, or is that assuming a particular ambient level?
It is, and generally the
It
reason,
is what?
assuming 0.
0.
And the reason we do that is because ambient fluctuates.
So, I'm just trying to understand your testimony, sir. So at Nichols Hill, your ambient is 53.43 dBA. At R1 and R2, you're saying it's approximately, you're anticipating the pressure being a 40.3 dBA increase. So what, in your estimation, would be the impact on R1 R1 and R2 based on the current ambient dBA.
So if at that period where it was
53.43.
thank you, it would be mostly swallowed up by that kind of noise. There would be a slight increase, as it's added to it, to your point. But if the sound levels are below, if your ambient goes below it, then all of a sudden that becomes more of a contributor.
And I'm sorry, I know you said this earlier, but couldn't understand you when you said it. What was the most contributing factor for that ambient being 53?
Traffic.
Okay. Any other questions from commissioners?
I have one.
Commissioner King.
What 3-day period did you do the study?
Off the top of my head, I do not have that. I can find it for you pretty quick though.
You said that was in October?
It was in October.
Any other questions from commissioners?
I got a question. So,
Commissioner Poyer?
the noise generated during oil and gas operations shall not exceed the average ambient noise level established in subsection 1 by more than, so it's 10 decibels during daytime hours, 5 decibels during nighttime hours. Who's gonna monitor that, and what if it goes over? Who's gonna be notified, or how are we gonna know?
Well, just one clarification, that it would be, it's 5 plus 24/7 for a compressor station, so it would be 60, but understanding the question,
So if I take, R1 and R2, so they're like 40.3, so if that goes at nighttime to 45.3, that's the max it can go?
no, the max is the 55 plus 5.
So the average?
The max is 60.
Okay.
And, I mean, just to answer your question, Mr. Poyer, the township does own, a decibel reader, so we would be in charge of enforcing that ordinance. So if we believe there's a complaint or there's an issue, we certainly could go down there and run whatever tests we would need to do, and then we would obviously notify the applicant if there was a problem.
I'd like to ask a question, Commissioner Bennett. So let's put it in like layman's terms. If you were sitting out back and no traffic was going by, and they're sitting on their back porch, are they gonna notice that?
If the ambient sound levels are below 40, yes, then it would be a noticeable thing,
So kind of like we're hearing this light right now humming?
potentially. October 17th through 19th, 2020. That was a Saturday, Sunday, and a Monday.
Any other questions from commissioners? Eileen Miskovich, any questions for this witness?
No,
Caitlin Bursick, any questions for this witness?
Yeah, can you tell me one more time the dates when you were monitoring the sound at Nichols?
October 17th, 18th, and 19th.
And do you know if that time the well pad, at the top of Nichols Hill close to Falling Timber, were they operating at the time?
I do not know that.
So, the 40.5 dBA projected at my residence, so just so I can understand it, that's all the time.
Yeah, so where's your residence?
R02.
Okay. So R2, we're predicting that the sound levels would be 40.5.
All the time.
Yeah, so we take the information that's going to be consistent, so all of the data that we have based on the manufacturer's equipment. And it runs consistently, so that's a pretty constant run, yes.
So, are there certain times that the compressor station makes, a louder noise? Is 60 the max amount
So, I mean, you know, as it operates, if there is a change in conditions, yes, there could be a change in noise levels. There are, scenarios where, like Mr. Conklin had spoken to earlier, where the station blows down, it's kind of an emergency thing, or, just a blowing off of gas. Those are historically very loud, events, but the equipment that Olympus is going to supply is very, I mean, it's, what was the term you used for it? For your blowdown silencers? The blowdown silencers you guys are utilizing are extreme silent.
Oh, yes, they're
One more time.
Sorry, I'm extremely quiet. So the silencers that they have would keep it from, you know, being out of compliance.
And then if it is, who would we contact? Our commissioner?
I believe that's the case is you would contact the township, they would contact Olympus. Olympus has a period of time to start monitoring for noise.
Does this account for, low frequency noise, or is this high frequency?
It includes all frequencies that we are provided. So, it was, I want to say, the data came with, it was third octave band.
Like,
So
what does that mean?
33 discrete bands going from low to high. So it would account for all of the frequencies that we can hear.
Okay, my only thought in asking those questions was, since I've lived there through the operations at the well pad at the top of the hill, there are times if right now, there's nothing going on up there, so the traffic levels and the noise levels are considerably less. So my only thought is, if something was going on out there when the sound was being monitored at Hill at that intersection, it would have like shown as much louder than it does all the time. So that was my only thought behind asking those questions.
Sure.
And is there a certain frequency that you can like feel? Because we can hear sounds, but there are people who are deaf, they feel vibration. So do you know anything about at what level of sound you would feel the sound as opposed to just hearing it?
Yeah, generally sub 63 hertz, things start to become more of a feel as opposed to a hear. It can be explained that way.
And so does that mean that anything in that range fall within a sound that would vibrate or you feel or no?
Yeah, I mean, I without looking at the data specifically, but I do know that it does account for, you know, broad spectrum.
Okay. I'm done.
Mr. Campus has a question?
Your, tech that you had, did the meter, can he do it right now?
He's not here. I sent him home. He's got a newborn.
I'm sure most of us play around with our decibel meters.
What's the saying here? So,
Sure, so I was gonna ask if everybody could just be quiet for a minute. Sixty-one decibels right here in a quiet room. Just so everybody can get an idea, when you talk about 40, 60, 100 decibels. 60. So you're 40, and I work in an industrial setting, plants, incinerators, and stuff like that. Wow.
Sure.
So you say a quiet room, this is 60. So just, I was hoping he'd be here.
What's it go up to when you talk?
When I talk, probably 75 or 80.
75, 80.
Yeah. Depends on if I bring out my singing voice.
Any other questions, commissioners?
So your average.
Mr. Walls?
Yeah, thank you. Your average, for the site, you say 53.43. Do you have like the data available where you can look that average?
I don't have it with me, but I do have it, yeah.
Okay, is that something you could
wasn't submitted.
Over a 72-hour period?
What is that? Yeah, we are that.
I'd like to see it. Let me, don't have it right now.
We'll get it, right.
Thanks. Thank you.
Any questions for this witness from commissioners? And Jen Roslin.
Just to, get back and get started, are you a sound engineer?
I am not. Excuse me.
An engineer of any kind?
I am not.
Do you, but what professional credentials then do you hold and particular certifications for this type of work?
So I've just been doing this for a pretty long time, but the person who performs the actual modeling is a civil engineer, an acoustician. He's a member of INTS. He has, a various, array of professional, organizational, affiliations. He's been doing this for over 20 years. He's done over 2,000 various, impact assessments all over North America, South America.
Your company, Acoustical Control, it does seem to have a large specialization in sound mitigation implementation, I guess I would say. And then, as an additional thing, the noise control services, which is where you're coming from in this, is that right?
Yes.
Yeah, okay. Has your company designed or manufactured or bid, entered a contract or sold the sound mitigation material for, that surrounds this particular, our champion, the proposed champion station?
No.
Your company has a civil engineer who's doing this. Do they have is there an actual sound engineer?
I mean, he's an acoustician. He's a civil engineer who's been practicing in acoustics for over 20 years.
Can you tell me exactly what might be sound? Is there a difference with a sound study and sound modeling? Can you tell me what's involved in those? Are they industry standards that regulator guide this kind of work?
When you say study, I assume you mean monitoring?
I've seen a lot of different terms employed. There's like sound studies and sound modeling and sound analysis and sound impact assessments and.
So they could all be considered studies, but in general, we're looking at two different things.
Okay.
We're looking at monitoring and impact modeling. One is where we collect data that's actually happening,
Yes.
and the other one is predictive analysis. So we take data, we plug it into software. That software takes a whole host of attributes and predicts what the sound levels are going to be. It's math basically. There's a whole bunch of calculations that have to happen to predict that.
Yes, I saw that. Looked like calculus to me. But,
Millions and millions of calculations.
yeah. Let's see. So in the end, for the map that we're seeing, that would be officially called a modeling.
Yeah, we would call it a sound impact assessment or a noise impact assessment, but yes, that is modeling.
So you apparently had taken the actual data for your 3-compressor model. Did you take new ambient data for this 2-compressor model that would be current?
We didn't utilize the ambient data in the modeling. We just used the manufacturer's data for the equipment.
What were the specific pieces of equipment in this whole compressor station that you did use?
So there's an engine or a take and let fans. There are a whole host of fans for airflow so that the building provides enough air so that it doesn't overheat and it satisfies a class 1 Div 2 environment, which is electrical code. And so there's a whole host of those things. There's also silencers that are put, sorry, they put those on any kind of penetration hole.
Yeah.
So if there's a hole in the building where they're gonna put a fan, they will put a silencer on it so that it absorbs noise as it comes out. And so they've done that. There's an exhaust silencer, which is extreme hospital grade. The insertion loss is exceptional. So I mean, when I say insertion loss, the number of decibels drops it. It's quite high. And then the building that we modeled had 26 gauge R panel, which is sheet metal. I believe it was 6 inches of 8 pound per square foot insulation. So there's a whole host of things that were included in.
So when you do this modeling, is it the kind of thing where you take each individual piece of equipment and in some way add them together, or do you just make a whole, surround, hi, this is all the equipment in this proposed site?
So we had drawings that we were given, and so basically we built a 3-dimensional model, and we put those point sources in. So say we have, a certain value that would be coming out of the building through a penetration, like the fan. Then we can take the silencer of that and then calculate that. So all those, there's lots and lots of little point sources.
And for each of these, you in some way got an actual value, like a sound power value.
Correct.
Is that right?
Yes.
And somehow combined all of these together. Is that what I
Yeah, so
understand you did?
you locate the point source, the sound power level of the point source on the model, or in the modeling software. And then it calculates all those point sources, all those data values. And then it takes into account topography and all those other things, buildings, silencers, and that's how that number is calculated.
And then you in some way, you're getting the sound power values from the manufacturers. I mean, is this theoretical, that something that they?
I mean, it's
calculate?
predictive modeling, so it's all theoretical, yes. But I mean,
So,
they have tested their equipment, and I mean, this is common practice to do.
But you've never gone out with like an actual handheld monitor to monitor like those big cooling fans. It looked like from some of the sketches I've seen, there's like something like a 4-foot diameter fan underneath the gigantic muffler.
Sure, yeah.
But those kinds of actual values that you may have modeled were not used, it's all theoretical.
Because we have the actual manufacturer's data of what they're going to use.
Okay. And so then you also have the manufacturer's data for the sound mitigating properties of the building in some way, or,
Yeah, so I mean, all the silencers to come with their data, their insertion loss data, and then the materials can be input into the software. Most of that stuff, comes, with the software, or it's readily available information.
so those are separately called something like the octave band insertion loss data for the building and for the silencers, and that all is added in together.
You could say that.
Let's see. When you did this model, you used new CEC sketch of the two model system, is that right?
That's correct, yes.
Okay, 2 models. And so when you did the 3 compressor models, that obviously had more noise, is that correct?
It was a different configuration as well. I don't
Yeah, it
really
was.
know exactly off the top of my head what the levels were.
Are those values that you had actually used of the actual sound power considerations, are those data available in your study, or could you provide those?
I mean, we have that stuff, yes.
So you could in fact, provide that to the commissioners, to us, so we could see what are the numbers that you're using. We understand somewhat how you got the ambient noise, but the other side of this is how did you get the values from the compressor station?
Sure.
Could you provide that, make that available, or commissioners, could you request those data, please?
Just to point out that the study isn't even required under the ordinance, but, we can provide it, if requested.
If you would, please, thank you. And this is just a side question. Again, I understand that any violation of the noise ordinances is going to be handed off to the township to enforce. Was that my understanding? No, this gentleman, yes. Let's see. You're then, familiar with the, ASTM, the American Society of Testing and Materials Standards and Noise Standards? Yeah. And the American National Standards Institute, ANSI, Acoustics and Noise Standards, and that's all incorporated in your work. And are you also familiar with the International Standards Organization, Acoustics and Noise Standards?
Yes, the software we use is 2 ISO standards.
Is what?
ISO standards.
And, so clearly you have followed all of the standards that were, all these national standards. And when you not modeled the noise, and once again, that was emitted by the compressor station, indeed you did follow the accepted, ISO standards?
Yes.
And what were those standards again, what did they come?
The software or?
Yeah, the ISO standards.
So the ISO standards that we are following are 1996, 9613.2, and then it was also updated in 2015 for some of this modeling software to standardize it.
So again, as the key point in this modeling, is the input of the sound power source, and the power level. That's the basic thing you're going for.
Well, I mean, there's a variety of things that we're accounting for. The sound power level of the equipment that we're modeling is a pretty key part of that, yes.
Just to be sure here, we've got, some aspects of this, ISO 9613, and, I would like to ask that it be admitted, into the record if I could.
Any objection?
No.
Will be
The equations to be used are for the attenuation of sound from point sources, extended noise sources, therefore such as road and rail traffic, or an industrial site which may include several installations or plants together with traffic moving on the site shall be represented by a set of section cells, each having a certain sound power level and directivity.
And so your source sound power levels were measured in accordance with these standards, is that correct?
They were manufacturer's data.
Okay. Would you agree that if in any way the source power levels were wrong, that the output of the model itself then would be wrong?
It would impact it.
And if the source levels are in error and too low compared to the true levels, then what effect would that have on the model?
It would affect it, but with any predictive analysis, you're using the best information you have available.
And would then the model, assuming that, let us say that it were to lower than what was used, if the real actual measured stuff was lower, the model noise would be then lower.
Could you repeat that?
If the actual value of the sound power were lower than what you used in the model, and what you used to put into the model, the output then would predict a lower
Theoretically.
value. Yeah, okay. How do you know your sound levels are correct?
It's been tested by the producers of the equipment.
And one more time, how many roughly pieces of equipment have been involved? You've got the compressor, you've got all of the air intakes, you've got,
Off the top of my head, I don't know how many point sources, but I can find that out.
okay. And in our friends, the ASTM and ANSI standards, do you know exactly what section or so you were following to measure the sound source power?
We didn't measure it.
Or the company?
So, I mean, companies like Caterpillar or, these large companies that are producing this equipment, it's a big deal for them. So they're going to follow the rules.
Have you done any validation testing of your model to confirm that it's accurate? In other words, did you, having thus predicted a value at some location at a certain distance, have you in any way gone out to actually measure it?
We haven't in this scenario, no.
When your crew did the ambient noise levels, were you able to perceive any difference in the nighttime levels? Or did
Levels vary throughout the day.
do you have those data available to just take a look at?
Yeah, it's in the report.
Okay. In your map, which you've had a predictive modeling going on, is there any, what you might say, deviation? Is there a plus minus to those contour lines? I mean, can you say give or take along those contour lines, a decibel level difference?
Yeah, I mean, there's a variable of 3 or so decibels with the modeling software.
Yes.
And as far as the ISO lines are concerned, You know, it depends on the grid size, you know, you can shrink it down or you can expand it out, so. And if you shrink it down, obviously you'll have a greater clarity.
Yes. But kind of roughing it about 3 decibels, you could say.
Yeah, that's the general kind of, assumption with most modeling software.
Okay, but,
Most modeling software is around 3 decibels.
let's see, that's close, now, at the conclusion of your report, and as the conclusion of this study, your conclusion, which I will read here in its entirety, is, according to the recommended mitigation scenario, compressor station operations would comply with the township ordinance's allowable limit of 60 dBA. You refer right at the beginning of a recommended mitigation scenario, and what is that scenario?
It's the scenario that was provided by Olympus, or Hyperion.
Where is this, do you have any idea where this scenario is located? I mean, it's not.
It's not required to be in the report, but like, to Mr. Lucas's point, we weren't required to do this. We're doing this as kind of a general kind of observation to see, to make sure that they're doing the right things.
And you're referring there to the recommended mitigation scenario?
Yeah, the building components, the silencers that are going to be implemented for all of the equipment, yes.
These are, I guess, scattered throughout the report. There's no consolidated mitigation scenario that I was ever able to find, although it would be very interesting.
Sure. So, I mean, it's a pre-engineered metal building with various low noise emitting equipment and silencers included.
Because your company is involved in recommending mitigation scenarios, did you recommend any of this scenario?
No, we just did the modeling based on the equipment provided by Olympus.
Okay, I think that's it for me at this time.
I have a question. So, these mitigation efforts, in your opinion, are there any other mitigation efforts that could be undertaken at this site that would, say, lessen the impacts on R1, R2, and R3 in your model, such as walls, trees, buffering? Are there anything else that could be done on this site?
Sure.
Aside within the, like what?
I mean, there's a whole host of things that you can do to increase, you know, attenuation, you know, whether that's a barrier, whether that's increasing insulation, whether that's adding, you know, insulation to certain pieces of equipment. There's a whole host of things that can be done.
Is there any, I mean, you were part of this particular study, correct?
Yeah.
Is there anything in your observation and your participation in this particular study that you would recommend in terms of lessening the impact on R1, R2, and R3?
Well, I mean, they're already in compliance based on what we're seeing. The equipment that they're using is state of the art. If you compare this to something that was built 10 years ago, everything across the board is better. They're doing the best with, like, each piece of equipment. They're doing what they're, like, state of the art, kind of the going above and beyond.
That's not my question, I understand that. My question is, are there other things, other mitigation efforts that can be undertaken at this particular site? So, for instance, you said barriers. Would putting up a barrier or sound wall do anything to the impact of R1, R2, and R3s, in your opinion?
Depending on the location, but yes.
Like what size and what location would be necessary in order to have a significant impact?
It would be something that we would want to look at and include in a mitigation model. But, I mean, you know, kind of your cooler fans are something that are low noise, very low noise, but are exposed. So that's something that's kind of low hanging fruit.
So what would you do to those? What does that mean?
I mean, we've, you know, enclosed them, we've put silencers on them, we've put barriers on them. Those are just some of the things that we've done.
Any other questions from commissioners?
Just following along on your thought, maybe you can answer this, the cooling fans, are they facing the back towards the, hillside? No, I can't remember the background.
So if I can answer, the cooler fans are actually facing upwards.
No.
The cooler fan model that we spec for this particular facility, if you notice, and I'll try and point here, these are, they're where? So these are, sorry. These are what I'd like to refer to as a horizontal cooler. So the fan is actually, so there are two styles. There are vertical coolers, and those coolers are where the fan points directly out from the building. And those are typically driven by the engine. And one of the disadvantages of those is they also typically sit right up against the building, so they cut a large hole, like a 15 by 20 foot hole in the mitigation of the building right next to the compressor engine, right? So if you can imagine that fan turned on its side and up against the building, now there's no mineral wool right next to the compressor engine, right? So that's the loudest part inside the building, and it's also now the least protected section. So we spec out horizontal coolers, so that fan is actually pointing up and blowing air up, right? And so it's not directly facing anything in the like in the elevation view there. And additionally, what that allows us to do is, you can see they're offset from the building roughly 5 feet, I'll say. That allows us to make sure that those mitigation efforts, like the 6 inches of mineral wool that Cage mentioned, are still present directly in front of the compressor engines too. So I think that helps with fans.
Exactly what I was.
Okay.
One last thing. If the mitigation, efforts, you refer to them as being exceptional. Are there data that demonstrate how exceptional they are, like that, for example, 6 inches of mineral wool is cutting the sound level by whatever percentage, and it's so much better than any other insulation?
Right, well, and so, I mean, we can look at that stuff and kind of identify weaknesses when you look back and kind of reverse engineer it. But, I mean, when I talk about, the building components really isn't the biggest, like, state-of-the-art thing. I mean, that's just, you know, a building with insulation. The state-of-the-art thing is the equipment being ultra-low noise, and then the silencing equipment that's associated with it.
So our Caterpillar 3606 is the quietest on the market, our compressor engine. Is that what you're saying?
For the requirements that they have.
And the fan, the cooling fan, which looked to me in the sketch to be almost 4 feet in diameter, 4 feet in diameter, 5 feet in diameter. How big are those?
Off the top of my head, they're roughly 10 feet diameter.
So like I've got this fan in the house, it's circular, I call the thing the Roaring 40, because of the amount of noise that rascal generates, and wind and cooling power. But, that, a 10-foot diameter fan we're looking at?
Yeah, and so there are multiple levels of noise mitigation apply to these fans. So as I noted in the previous hearing, these are what's called minimum acoustic geometry or MAG fans. So they're a special low noise generating fan that are specifically designed to generate very little noise. Additionally, one of the reasons the fans are larger is that we like to minimize our tip speed, because the buffeting of the tips of the fan can create noise as well. So we limit our fan tip speed to below 10,000 feet per minute to ensure that's an additional layer of noise mitigation. And also, we equip our large fans with variable frequency drives. And what that allows us to do is, so we have to size our fans for the hottest conditions, right? So they're designed for 120-degree day in order to continue to cool the gas, to cool the engine coolant, that sort of thing. We don't have a lot of 120-degree days around here, so we have a curve inside that's built into the control scheme in the facility that slows those fans down whenever they're not needed to run full capacity as well. So again, numerous layers of noise mitigation built into those fans.
May I ask one more question? And I promise.
Yeah, go ahead, because we've sort of opened up a.
Yeah,
We've got a little,
okay,
got a
just
little
say-
out of order here, and I apologize, but we're trying to make sure that everyone gets their questions answered. So I typically wouldn't have witnesses bouncing back and forth and whatnot, but, being that we've already, let that out of the bag, go ahead, Ms. Person.
I promise it's brief and to wrap it up. So it sounds to me like you're saying everything going into this already is this equipment and it's new equipment, state of the art, designed to make this compressor run as quietly as possible. And then I just want to know the additional sound mitigation, is that something that you would, could be added in addition if it just doesn't run as quietly as it's supposed to? Is that when you visit, like, okay, now we can add a wall, or we have this, or we can close it?
I mean, if
Because if it runs the way it should,
there shouldn't be any compliance issues.
correct. And then I'm just saying, if it doesn't, is that when the commissioners discuss with you, like, with the conditional use permit, like, okay, now we can add different things to be compliant? Right?
I mean, you certainly can add it after the fact. That's more common than not in a lot of places, but, my experience with Hyperion is their goal is to not be in that position.
Okay, so to just make it be compliant to the use. Okay, I'm done.
Any other questions? Yes.
You're an expert. When you do your sound studies, you're on a flat ground. You're on a flat,
When
you're up in Apollo, okay? When you're up in Apollo, and you do your sound study up there. Would that make a difference being down where they wanna have a champion? Because now you have a hillside on both sides.
We include elevation in the models.
Even the hillside,
Yes,
and that's what you came up with.
yes.
The condenser, what's the rating on that, on the models that you have?
The condenser?
Yeah, I wanna know what the noise level is on the condensers.
You mean the compressor?
Condensers.
I don't know off the top of my head. I'd have to look at the computer.
Brody, would you know that?
Are we talking the process?
Noise level on the condensers. Off the compressor?
I'm sorry, I'm not sure what you're referring to as the condensers.
Okay,
No,
okay.
Any other questions from commissioners? Mr. Lucas, any redirect? I don't know when we're at anymore, but I'll call it redirect. I'll call it
No
redirect.
redirect.
For either witness.
you know how to vote, take care of it.
Okay. spoken to you this morning already? Just swear in the witness, please.
Yes,
Ms. Hoffman, what is your position?
I'm the Vice President for Environmental Health, Safety, Regulatory, and Communications at Olympus.
And in that capacity, doing with the historic journal high blood pressure and the schedules that were implemented for all of the school pass.
I am.
Mr. Roosevelt testified about an ambient study that was done on October 17th, 2020. You recall that?
Yes,
Was there any drilling or hydraulic fracturing activity taking place at either the Apollo or Cruise well pad on those days?
there was not.
That's all. Thank you.
Any cross for this witness from the parties?
No,
Ms. Roslin, okay. Thank you. Mr. Lucas?
Hyperion's resting their case.
Okay. So before we get into the party case, we're gonna take a, 6-minute break. 6.5, no. I always say 5 or 6, and then it ends up being 10, so take 5 minutes. Let's try. Give her a chance.